All right, guys, this is the next to last section here. We're going to be talking about inverses of matrices. So we'll just dive right in here again. This is it adds on to what we're talking about with determinant. So this is, if you understood determinants, then you're going to be able to understand matrices or inverses as well. So it says, as shown in the previous section, if matrix A equals this, and we remember this little format again from determinants, it says, and the determinant of A does not equal 0, then the inverse of A, and I want you to look at this notation right here. It's got A to the -1 power, okay? So when we're talking about inverses, this is kind of how they notate inverses, is A to the -1 power. Okay, so it says that the inverse, or A to the -1, is 1 over the determinant of A. So it kind of reminds you of like the reciprocal of the determinant. In other words, if you have the determinant of matrix A and you put it under 1, then all of a sudden that would be what the inverse is. And then it gives us another little scenario here. Okay, so you notice I want to compare this, which is what they talk about with determinants, versus this is what they're saying the inverse is. So let's just look at what really happens here, and then I think it'll make a whole lot more sense. So what if you notice A and D, A is in the top left corner, D is in the bottom right corner. Well, notice what happens over here when we're talking about the inverse. These two just switch places, okay? So that's basically all that happens here. Now notice the B and the C, they're in the same exact position, but now all of a sudden, instead of taking the positive of those two numbers, now we're taking the negative of those two numbers, or the opposite, okay? So it makes sense because when we do inverse operations to solve equations, for example, which we're going to do matrix equations tomorrow, or Monday, I guess it would be, but when we do equations, when we solve equations, we have to use inverse operations in order to do that, right? And so that's basically what we're doing here. We're just switching out A and D, and then we're taking the negative of the two values that would have been up here, okay? So again, for a 2 by 2 matrix, this is actually a pretty easy proposition. It's not really hard at all to be able to do that. However, just like with determinants, when you get to a 3 by 3, and again, it uses the same rules as determinants. You have to have a square matrix in order to be able to do this. But in order to do a 3 by 3, it gets a little more complicated. As a matter of fact, look here. They're saying find the inverse of matrix A, and they give you this problem, which is a 3 by 3. And even the instructions tell you to put the 3 by 3 matrix into the matrix function of the calculator. They're like, don't even try this, okay? So really, I want to focus on that, I guess, because the rest of your practice, that's really what it is just practicing using the calculator and learning how to find the inverse, okay? So if you go over here to the second page, which will be the second page for you, it says find the inverse of each matrix below using a graphing calculator. Again, they just tell you just go ahead and use the calculator. Then it says if no inverse exists for the matrix, write none, okay? You're going to put some of these into this matrix calculator, and it's going to come back with an answer and tell you, hey, this matrix does not have an inverse, okay? And in that case, you just write none. And then the last note is just give your answers in fraction form. So some of these will be in fraction form. So what I want to do, I want to look at number 1 here, and then we're going to look at another one here in just a few minutes. But I'm going to go ahead, just like we always do, let's think about the dimensions. I've got 3 rows, I've got 3 columns. So this is a 3 by 3, okay? So that's what I'm going to need to put into my matrix calculator. I'm going to go ahead and just bring up the matrix calculator and do new matrix. And again, I'm going to change this to a 3 by 3 so that I can go ahead and put in my values. So I have -1, 1, sorry, it wasn't negative, 0, -1, 0, 1 is my second row. My third row is 6, -2, and -3. And again, like we always do, I want to go ahead and just click this blue return button so that it kind of puts that into my calculator. So it's stored that as matrix A. Now, remember our sign that we talked about for matrices and finding inverses is that A with the -1. Well, you see that kind of right here, already over determinant, right? But what you actually have to do in this case is we have to go ahead and put in A, because that's what we're talking about. And you notice it repeats that matrix. But then I'm going to go ahead and click this A to the -1 right here. And you notice what it does. It goes ahead and it changes this over here to indicate what my inverse is. So this is my original matrix that I was working with. This is the inverse of that matrix, okay? So all of this right here would be your answer. That's actually what you're going to put into your form. So first row is 2, 3, 1. Second row is 3, 3, 1. And third row is 2, 4, 1. So we would write that in our form right there, and that would be our answer for number 1. Again, if you do that process, and notice some of these get big. This here's got what, 5 rows by 5 columns, 5 by 5. Okay, this one here is actually a 5 by 6. So we'd have to try that, see if that's going to work or not. Again, if it says it cannot do it, then it cannot do it. All right. So then we're going to move down here to 13 through 15. So there are 15 problems today, but again, it's mostly just calculator work. This one here, it says determine if matrices A and B are inverses of each other. Again, you could do this manually, but I'm going to show you how to do this on the calculator because these other two that you're going to do are 3 by 3s anyway. Okay, so let's look at this first one. So what we're going to do is we're going to put in matrix A, and then we're going to do the inverse of matrix A and see if it matches what we have over here. Okay, if it does, then we know that these two are inverses of one another. If it doesn't, then we just write no. Okay, so all I'm really focused on right now is this first matrix right here, matrix A, and I'm going to go ahead and put that in my matrix calculator. So again, if you've already got some stuff in your matrix calculator, you can just hit clear and then clear all, and it will clear everything out for you. So we're going to start with a new matrix again. Again, that was a 2 by 2, so we're going to leave that just the way it is. I'm going to go ahead and put in my first row, which was 5, 3. My second row was 3, 2, and I'm going to go ahead and store that in my calculator. Now remember, in order to find the matrix, I'm going to have to tell it which matrix I want, which in this case is matrix A, and then I have to tell it I want to do the inverse. Notice what it does. It changes this to my inverse, and it tells me that the inverse of matrix A, which is this one, is 2, -3, -3, 5. Let's compare that to what we had over here. 2, -3, -3, 5. You notice that those are exactly the same. So we can conclusively say that matrix A and matrix B are inverses of one another. So in this case, we would just write yes, is all we have to do. And you do the same thing for these two to see if they're no. I do want you to notice right here that this has some scalar multiplication with it, okay? So you've got to make sure that the answer this gives you is this matrix times 1/2, okay? So that's pretty much it. Again, not really difficult, just one of those things we have to kind of learn as a new task. A new way of doing things with this matrix calculator, but hopefully you are enjoying this and you're learning some new stuff. That's pretty much it for today. Thanks.